Hello, everyone. I'm Lori DeToro, Communications Manager for Turntide Technologies. Thank you so much for joining us today for the Current and Wave webinar covering the circular economy of electric motors. We are very pleased to have Turntide Apps engineer Matt Lamb presenting for us today. Before we get started, we have some housekeeping tips to share. This presentation is being recorded and will be available on demand on the Current and Wave website in about 48 hours. We will be taking questions at the end of the presentation, so please use the Q&A section, that's the one with the question mark, not the chat section, to ask your questions anytime during the webinar, and we will answer as many as possible as time allows. We also have a link for our September webinar in the chat, so please go and register for that before you log out of this session. Remember, again, I say this every time, this is a live event, so when we mess up, and we probably will, laugh along with us and understand that we are really live. I think that's it for housekeeping, and we're ready to go. Matt, let's get started.
Well, thank you very much, Laurie. Thank you very much for that introduction. Good afternoon from here in the UK and welcome. It's great to have you all on what is currently actually a very lovely sunny Thursday here in Newcastle. My name is Matthew Lamb, and this is my presentation on the circularity of electrical machines within the UK automotive industry. I'd like to start by explaining a little bit about myself and why this topic is important to me. I'm an engineer with 13 years of experience working in the automotive industry, and I have a background in design and development of power electronics and motors. My current role as an applications engineer involves working closely with our customers here at Turntide and also with our key business partners and collaborative organizations. And over the past few years, I've seen sustainability, and in particular the circular economy, rapidly growing as a requirement across the industry. The key topics we're going to cover today are an introduction into the research I carried out as part of my master's with Cranfield University on the circular economy of electrical machines used in the UK automotive sector. This involves an overview of the research process and discussing the results, including reviewing the opportunities, the drivers, the barriers that currently exist within the industry, and then identifying potential mitigating strategies for these areas. I will then showcase the circular economy model I have developed from these findings. And finally, I will discuss the iterative implementation methods that can support businesses to adopt some of these strategies. So with that in mind, here's a brief background on the status of the circular economy within the UK automotive sector. The automotive industry is currently experiencing a step change transition from the use of combustion engines or ICE vehicles to greener technologies involving electric and hybrid vehicles. Now, this has been described to me as the biggest shift the automotive industry has seen since the manufacturing of the Model T by Henry Ford. So that's a once in a generation opportunity. To give some context to this, in 2022, electric vehicles and hybrids consisted of 50% of newly registered vehicles in the UK, and this is compared to just 1% 10 years ago. And this shift has significantly increased the demand within the sector for electrical machines. Most electrical machines currently used in the automotive sector are designs that utilize permanent magnet motors, and historically these have been manufactured using linear manufacturing models, and this is where products are produced, sold, and upon their end of life they are discarded as waste. And this slide gives an example showing an exploded diagram of an electric motor or generator. Specifically, this is an internal permanent magnet machine. So I'm just going to get my laser pointer and point out some of the key areas for those not so familiar with motors. We have here the stator, which is made from electrical steel or silicon steel. You then go into the copper windings. Another key area of the motor is the rotor section. And in this example, this is also made from silicon steel or electrical steel. Then we have rare earth magnets up here. You then got your bearing, which can be made of steel, or the ball bearings can be made of ceramics. And then obviously you'll have the shaft going through the motor here, which again can be made from a number of materials, but steel is predominantly used in many machines. And then there's also things like the casing, and you have the seals that go with that as well. So there's a huge range of materials and that are used in a motor design. And as I'm sure a lot of you on the call will understand, these motors require high quality, high grade materials for operation in the challenging automotive environments. For example, very high temperatures and vibration. And this high grade and quality is often accompanied by a very high price. Now, an example of this is the quality and grade of magnets and electrical steel, and these are intrinsic to the performance of an electrical machine. Many of you may have read recently in the media about the challenges faced by businesses and supply chains worldwide in gaining access to materials due to trade wars and also the geopolitical climate. I was at the Coil Winding, Insulation and Electrical Manufacturing Exhibition, also known as QIME, in Berlin back in June earlier this year. And these specific issues were key topics of discussion throughout the week. And now for those of us who aren't so familiar with the circular economy, this is one example of the circular economy, which is called the Circular Economy Butterfly. And this was developed by Ellen MacArthur Foundation. Now, they describe the circular economy as where products and materials are kept in circulation through processes like maintenance, reuse, refurbishment, remanufacture, or recycling. And one of the key aims of the circular economy is to keep the product and the materials at the highest level as possible. This prolongs the length of time a material is used within a product and thus decouples economic growth from material extraction. And that's a key fundamental principle. Regarding electrical machines, copper is a very good example of this, with a risk that in the near future, the growth of the electrical vehicle sector could be limited by the quantity of mined copper. Therefore, using the circular economy as a strategic model could be an effective way to support the sector to not only achieve its environmental goals, but also do so without impacting upon sector growth. Now, before I move on, I have a question for you to think about, and that is, do you think this model is simple and easy to implement within your business or your industrial sector? I want to highlight here a report that in my opinion, is very important. The Circularity Gap report is produced by the Circular Economy Foundation, and this is an NGO that's based in the Netherlands. It essentially provides an overview on the circular economy across all industries and sectors worldwide. One of the key parts of the report discusses the circularity metric, and this is a high-level measurement of the global circular economy. And concerningly, this has dropped from 7.2% to 6.9%. And you may think, well, so what? It's only 0.3%. But this is 0.3% of a figure that is already low. And the direction and the associated trends that go with this are worrying. And recycling is actually increasing in terms of volume, but that's not at the same rate as raw material extraction. And this really highlights where the focus and investment from the supply chain currently is. The report also highlights that mobility and transport systems are a high impact sector with regards to the circular economy. And so small changes through this sector can have real potential for real impact, substantial impact globally. So why now, and why focus on electrical machines? Well, as we've just discussed, there's a growing need to introduce more circular practices within industry, particularly with products like electrical machines, which require expensive, carbon-intense materials like metals and rare earths. And incidentally, these types of materials have been highlighted by the European Commission as critical raw materials, or CRMs. OEMs are becoming more ethically aware, and they're moving to reduce the environmental impact of their products and improve their ethical and sustainability credentials. However, more research is needed to develop the particular models required to tackle the sector-specific issues and challenges. Now, I'm going to give you a brief overview here of the research methodology used to investigate this problem. And the first part is that I reviewed the status of the automotive industry to understand the benchmark. This was before investigating best practices, definitions, and models of the circular economy. I then engaged with key stakeholders from the automotive sector using questionnaires, interviews to gather data and to support the understanding and identifying of the key drivers, the opportunities, and the barriers for businesses introducing circularity principles. Using these findings to identify and create more robust mitigating strategies, I was able to develop a pragmatic circular economy model tailored for electrical machines used within the UK automotive industry. I will now go over the key themes and findings from the questionnaire results. Starting with the opportunities associated with introducing a circular economy, participants identified environmental impact, resource efficiency, and economics or cost savings as their top 3 opportunities. Legislation and economics were by far the 2 biggest drivers, and the lack of legislation and perceived high cost of change were 2 barriers most often mentioned. Mitigating strategies against these barriers again included the introduction of legislation and cost benefits, but intriguingly also included product design for sustainability and collaboration between key stakeholders. The 5 main themes discussed during the interviews were automotive sector status, opportunities and drivers, barriers, enabling strategies and models, and foresight. Again, legislation and economic factors were prevalent throughout the discussions. However, in the absence of legislation, it was highlighted that businesses could combine the use of standards and auditing to drive change within their own sphere of influence. For example, their own supply chain. Also, introducing circular economy practices to the concept phase of a product instead of at the end of the design cycle as a type of bolt-on solution was seen as key to the success of implementation of these practices. Once the data from the questionnaires and interviews had been collated and analysed, the next stage involved the triangulation of the findings, and I will summarise this for you now. The themes that were most prevalent were that the automotive sector, as previously discussed, is going through a sector-wide transformation in moving from ICE vehicles towards EVs and hybrids. This was also described as a huge opportunity to drive the automotive markets away from linear models to more circular structures and markets. However, these markets and these opportunities are not currently being realized by the sector. Tangible business models that are to be successfully integrated into industry need to be simple and they need to be easy to understand. There's a really good paper by Julian Kircher that states that there are 221 different definitions of the circular economy. Now, this is both confusing and unhelpful, and it's clear from my research that simplicity, clarity, and adaptability are key for enabling businesses to adopt new processes. But the model must also be flexible enough to allow businesses to adapt iteratively to changes within the market, including the detail required to incorporate the complex range of materials used in an electrical machine. Again, linking back to the butterfly model that I discussed earlier on, how complex would that look when applied to all of the components and materials in an electrical machine? Key barriers to implementing the circular economy strategies were highlighted as a lack of legislation and economic incentives, a lack of ownership regarding technical and manufacturing issues, and a culture where second-hand or refurbished products are seen as a lower value and not as good as new products. Would you be happy to know that your car had been manufactured using refurbished components? And would you expect to pay less for that vehicle? The most effective mitigating strategies were design, introducing circular economy requirements into the concept phase and early design phases of the product development, education of key stakeholders, collaboration between businesses and also with academic institutions, and finally, where legislation and regulations are lacking, businesses should introduce their own standards or ISO standards in conjunction with auditing to proactively drive and promote change. All these points were considered when developing the circular economy model, which I will discuss with you on the next slide. So I'm going to explain a little bit more about the model I've developed, starting with the model in its most basic and fundamental form. So my model is based on the value hill developed by Elysia Achterberg with the Circular Economy Foundation, which was also served as the framework for the European Commission's categorization system for the circular economy. Now, the circular design phase is where the sustainable design of an electrical machine occurs. And this is from the concept all the way through to the manufacture. The machine then enters its optimal use phase, and the aim is to keep the product and associated components and materials in this phase for as long as possible. Now, to support this, you create several processes and system loops under the value recovery umbrella, and that returns the product and associated materials to the optimal use phase. And I'll explain that in more detail on the next slide. Starting with the circular design. Now, as I'm sure many of you have first-hand experience of, any successful product design begins with a comprehensive concept plan. Including discussions on the circular economy practices at this early stage is critical to understanding the questions that need to be asked and the challenges that will be faced, thus addressing these at the earliest part of the design phase. This should include introducing circularity design gateways into the project and assigning the correct stakeholders to key responsibilities. And at the very least, this gets the team thinking about and likely including more circular design practices like designing for sustainability or designing for reduction of materials, designing for remanufacture. And this can all be done with maintenance and material recovery in mind. As more design information becomes available to the team, processes like supply chain mapping, simulation, and also audits can be started, followed by product lifecycle assessments to standards like ISO 14064. Moving into the procurement of raw materials, supplier audits can ensure high standards of material and component quality, whilst encouraging a high degree of circularity. It can also ensure suppliers operate in a socially responsible way, both in their operations and their sourcing practices. Following the product validation and sign-off processes when manufacturing is ready to commence, it needs to be done to the same high standards and requirements that we set to our suppliers. And finally, before any product is shipped, the robust end-of-line processes need to be followed to ensure high quality of product is shipped to the customers. The quality of the processes needs to be supported by continuous auditing to ensure compliance with the standards, as well as ISO standards, as well as customer and legislative requirements. The product then enters its optimal use phase for which it was designed. And as previously mentioned, the aim is to keep the product and associated materials within this phase for as long as possible. But inevitably, the product will then age and it will eventually, the components will reach their end of life. And so we will then enter the value recovery phase. One of the most successful methods of increasing a product's lifetime in optimal use is through product maintenance. For motors, this includes things like the lubrication of the bearings, the shaft alignment, cleaning of the case and seals, and also the mounting points. Once the maintenance has been completed, the product should then go through a quality sign-off procedure to ensure the standards are maintained. And this ensures that the value of the product is maintained at a high level before it re-enters the market. Next, we have second life. And I think it's very important to consider this at this point, as the opportunities for second life applications are likely to change. This is depending upon the product and its application use. It might be that a product needs to be refurbished first, or that it's suitable to be shipped straight to a customer. But the important thing is that second life is considered relatively high up the hill to maximize this business opportunity. The next step in value recovery is product refurbishment. And this would include the simple replacement of parts that have reached their end of life. For example, replacement of the bearings and the seals. These are relatively simple processes, but still require manufacturing expertise. And so this feeds back into the manufacturing step, followed by the quality checks, and then back into optimal use. Similarly, we have the remanufacturing of components that are a little bit more complex and may require a full disassembly of the product and potentially involve sending components back to sub-suppliers for remanufacturing. This includes processes like rewinding of the stators, or if possible, replacing the magnets or other components like the shaft. Recycling is the final step of material circularity, and this is applicable at any point in the process where waste material occurs. Once a component can no longer be used in an application, its raw materials need to be recovered as much as possible and then recycled, thus closing the loop for continuous use. Finally, at the bottom of the model, I have included a review. And by this, I mean a full overview of how the circular system is performing. Which areas are working well? What areas can be improved? This understanding and information flow is extremely important when iteratively implementing this type of model into a manufacturing process. And by iterative, I mean that the processes are continuously under review, with the objective of improving them. Now, if I remove some of the text, we can clearly see the circular economy model tailored for electrical machines used in the UK automotive industry. Following the three phases of the value hill, circular design, optimal use, and value recovery, this creates a simple and easy to follow structure that can be adapted to suit the needs of businesses, the product and applications, as well as the supply chain, customers, and other stakeholders. Having said that, the model itself cannot support change if it cannot be integrated within a business's current processes and practices, with minimal impact and relative ease. So implementing it requires a strategy. If possible, circularity should not be a bolt-on solution and requires businesses to take ownership of the issue early in the design phase and drive change. This will influence the design of the product from concept all the way through to production. However, if your aim is to improve the circularity of products currently in production, engaging with and collaborating with key stakeholders in your customer base, as well as your supply chain, is fundamental for developing, for implementing iterative improvements that are resilient and will make a difference and have an impact. Finally, ensuring that changes are implemented iteratively and managed effectively with a clear review process for information sharing that will confirm that changes are having their intended impact. So this circular model builds upon the key findings from my research to provide a framework based on industry's best practices that can help businesses to move away from linear manufacturing models, thus utilizing the opportunities presented by entering a more circular economy. And it also allows businesses to take ownership quickly by iteratively implementing change, however small, within their own sphere of influence. This will allow businesses to learn fast and move in an agile way. A key aim of the circular economy is to keep each component as high up the value hill as possible throughout its life. This prolongs the length of time a component is used within a product and thus decoupling economic growth from material extraction. Given the importance and expected growth of electrical machines used within the automotive sector, using the circular economy as a strategic model is an effective way to enable the automotive industry to achieve its environmental goals and support resilient economic growth. But I believe this research has really supported these fundamental aspects by developing a simple model that supports mitigating against some of the key barriers and also showing how businesses can take ownership to move away from linear manufacturing models and iteratively introducing circularity into their processes in a way that works for them, works for their supply chain, and also works for their customers. Now, before I finish, I would like to say a few quick thank yous. Firstly, to Turntide Technologies and also to Cranfield University for supporting this research, and also to my supervisor, Adriana, for supporting me through this process. Laurie, thank you very much for organising this webinar. I do appreciate it. If you want to read more about this research, it will be published soon in the Sustainability Journal, and I will publicise this over LinkedIn. Before I leave you, I would like to show a quote from Ellen MacArthur. If we could build an economy that would use things rather than use them up, we could build a future. Now, as an engineer, I believe that the circular economy presents one of the most challenging problems to solve, and will require the best brains in the business collaboratively working together to do so. But if we are to build this kind of future, we must make a start, for the sooner that we start, the sooner we will succeed. And for me personally, this mill means building a sustainable future, not only for my kids, but also for theirs. For this has to be the ultimate goal. Thank you very much for listening. That is now the end of my presentation. I'll be very interested to hear any questions or comments you may have.
Matt, that was amazing. Thank you so much for the great presentation. I'm so happy you could be here to present with us. We're going to start taking questions. So please continue to ask more if you have them. We'll get to as many as we can. And if we don't get to all of them, we will post a blog on Current and Wave to answer these questions. And Matt, we do have a first question is, does this model apply to manufacturing of axial flux motors?
Yes, very good question. Thank you very much for that. So you may have seen over the past few months some publications from Turntide. We are in the process of releasing our next generation of motors. And there is, if you have seen it, then great, but there's a really good webinar, one of the previous ones done by Laurie, from our director of multi-physics, Adam Nixon. And that really goes into a lot of detail about the new motor designs. And to answer the question succinctly, yes, we are implementing these types of strategies, and at the minute we're focusing on reduction. So reduction of materials, optimization of design, optimization of the manufacturing process, reducing the waste material that comes off that. So that's what this current generation is focusing on at the minute. But if you haven't seen it and you are interested in the axial flux motors, I highly recommend that webinar from Adam.
It is a great webinar, and it is on demand on Current and Wave, so you can go and watch that on demand if you haven't seen it. The next question we have is, how is it decided which subcomponents are expected to be refurbished and at what expected interval, and which subcomponents need to be designed to infinite life?
Yeah, that's a really nice question. Thank you very much. So to go for the first part, how do you look at the different components and decide which phase we'll go through? It really depends on the application. So if you think about the copper windings, and if they might have a certain type of insulation on them. Some copper windings are potted in certain motors. So a lot of it depends on the manufacturing processes and the topology of the motor itself. Some components may be easier in one type of design to refurbish or remanufacture than in another. Bearings is another good example. There are many motors where the bearing is very simple and easy to take out and replace. And I've read a lot of material on, I think there's a lot of studies that have gone into bearing replacement and the increase in life that can have. There will invariably be parts of the motor which will at the end of that life, the whole system will need to be replaced. The magnets can be one of those in many applications. If a magnet is glued into position, some magnets are epoxied or epoxy rare earth magnets that are molded. They are notoriously difficult to dismantle from rotors, and you know that would mean the whole system um, would need to go in for recycling. But again, if you look at this and you ask these questions in the design phase, you can really address these problems, and you can make it easier to then extract the materials if possible. And it also can help inform your material choices if you have a range of materials that you can use.
Excellent. Next question is, where in the circular design process would you say you got a thumbs up from the person who asked that question? So that's good. Where in the circular design process would you say that training and education would be the most effective or beneficial? Which is a great question.
Yeah, my honest answer to this is throughout. There will be learning that happens all the time, and I think that it, the, it's good to understand the basic fundamental principles at the start. I think that is a very good, strong position to be in. But then as you go through the process, you will inevitably learn more about what's possible. Industry processes will develop and change. There's currently at the minute there are huge developments happening in the UK and actually in Europe as well regarding magnet recycling. And the capabilities that are within that industry, it is small, but it's scaling quickly, and they're targeting different areas all the time. So the learning of what's possible, that is always changing, and as a business you will learn what works for you, what works for your supply chain, and what doesn't work for you, which is almost as well, not it can often be as good. And sharing that knowledge throughout all the different entities and design teams is really beneficial. It can really help to improve and speed up the process. That's why the very last part of the value recovery for me is knowledge sharing.
Excellent. And an add on to that, when would you include partnerships or outreach to cities and public entities or agencies? With a parenthetical note, thank you for this webinar. It's great. So
Oh,
good to hear. So thank you. But when would you reach out to partners and public entities during this process?
so in my opinion, in my personal opinion, collaboration with academic institutions isn't happening enough, and that came up time and time again during my research that I carried out. And I think that so that's one part. I think that I think there are institutions like Innovate UK who help and promote these types of things, but I think that there needs to be more collaboration between industry and academic institutions as a general rule of thumb. Now, other I think that maybe from an infrastructural point of view, the UK recycling infrastructure, there's been a lot of comments on that over the past 2 years. It's currently a topic of subject in the House of Lords that's continuously being reviewed. How equipped and how adapted is the UK for recycling EV vehicles? And the answer is that the blunt answer is that it isn't. And I think that um, the government needs to understand more about what needs to be done, what industry needs from a recycling and infrastructure point of view. That there are governing or support organisations. The Automotive Alliance, Northeast Automotive Alliance is one such that we are affiliated with. But there are other local ones that you can get involved with and ask these questions and ask them in a direct way that really focuses and puts the emphasis to drive change. Because I think a lot of the times these questions are asked and well it's difficult and it's challenging, and we know that already. So actually ask them in a poignant way and follow that up and really target that, because if we all do that, that will actually drive some and hopefully create some change.
Excellent. Next
I
question.
hope
While
that
you,
answers their question.
uh,
If it doesn't, please respond back.
yeah, I think it did, but they can also ask another question if they would like. Um, while you focus on the automotive industry in this presentation and in this model, does this apply to any vehicle manufacturing?
I think you can optimize this model to a huge range of different applications, yeah, and sectors. Um, like I said, I've based it on the value hill, and that has been it has been used in some areas by the European Commission, and I think it's one of the things I really like about it is how flexible it is and how easy it is to maneuver. And depending on what your sector is, circular economy models do need to change. The service sector, the finance sector, manufacturing sector, they're all very different, and they all will focus on the circular economy in a different way. And so that's one of the things I do like about this model, is how easy it is to adapt, and you just take things in, add things in that you think need to be there, and remove things that you feel aren't necessary, and then iteratively develop that as you go. Because again, you will find that certain things work and certain things don't, for different applications and for different supply chains. So I think that's important.
Okay, we have another question. So, does this circular economy model apply only to motors, or are you looking at other technologies like maybe inverters or batteries?
Yeah, so there are other governing for batteries. If I just take batteries as an example, there is the battery regulation, which has been put in force by the European Commission, and this is something that we are obviously looking at as a business, and working towards. And there's this, I think that there's a huge dynamic thing happening at the minute in the world of European Commission legislation. There was an omnibus released back in spring, which has really tailed back a lot of the environmental requirements. And indeed, about a month ago, the next deliverable for batteries was pushed back 2 years to August 27, I believe. So there's it's very dynamic at the minute, and I think we need to be aware and alive to that. But that doesn't stop us from introducing the models and the processes that we're developing. And in terms of applying this model to other our other products that we have, to answer the question in short, yes, we are doing that. Batteries is a key area. Inverters, less so. There's less that you can do, particularly from an electronics point of view. But we are exploring. We are engaging with our suppliers to see what's possible. And as I said previously, the art of what's possible is changing, and the limits of what's possible are moving all the time. So it's really important to stay on top of that.
Well, that was our last question. So, thanks again, Matt, for this very informative presentation. We appreciate you taking the time to join us. So, we appreciate that.
Thank you very much to everyone for joining. It was a pleasure to be here.
And attendees, thank you for joining us as well. This webinar will be available on demand in about 48 hours. We hope you'll join us for our September webinar. Again, that registration link is in the chat. We hope you all have a great week. And thanks again for spending time with us today.
Thank you. Bye bye.